Accessibility is the core of one of the areas of action of the European Disability Strategy 2010-2020 and the Strategy for the Rights of Persons with Disabilities 2020-2030. Culture is one of the most crucial contexts in which accessibility is declined, because of its centrality in the growth of both the individual and the society. The EU-funded Erasmus Plus project, Invisible, inclusive and innovative learning tool for visually impaired and blind people, aims at answering to this need for inclusion, improving access to cultural contexts in higher education for people with special needs. The project chooses to focus on education of visually impaired and blind people, particularly in that field that apparently excludes them, the so-called visual arts. The main objective of Invisible is to equip courses in history of architecture with advanced technological solutions, interactive pedagogical methods, and innovative didactic tools that make them accessible also to students with visual disabilities. One of the main tangible objectives is the creation of guidelines for the design and realization of 3D architectural models accessible to visually impaired and blind people. The Invisible guidelines will allow all kinds of users to follow the entire process of creating the models and adapt it according both to different users' needs and 3D printing process complexity. For this objective, several case studies have been selected and developed in collaboration with the COVER project. While the two Erasmus Plus projects have different objectives, they share a common focus: the construction of 3D models of historical architectures. Part of the know-how developed within the COVER project was used to create the 3D models for Invisible. Specifically, digital 3D models with certain characteristics are necessary to carry out 3D printing. 3 different projects were selected as experiments: the Tempietto by Bramante, a Palladian villa, a never-realized project classified as Villa Valmarana by the RIBA, and a Propylea building by Ledoux. Those case studies were originally created within the Unibo Architectural Drawing Laboratory course of single-cycle degree Bachelor and Masters in Architecture. As for the qualities and characteristics that a 3D model of a virtual reconstruction should have, we refer to the lessons on best practices in this course. Here instead we will focus on the issues of 3D printing for models intended for people with visual disabilities. The 3 architectural models were developed with features, size, materials, scale, etc., suitable for tactile exploration, making them accessible to visually impaired and blind people. The basic idea was to highlight the most important spatial and formal information of these architectural projects. In the case study of a Palladian villa, various 3D digital models were developed at different scales: a 1:100 scale 3D model, a 1:100 scale 3D model of the main plan, a sectional model of a quarter of the entire model at 1:50 scale, and some details at 1:20 scale. It was necessary to rework the digital 3D models to print them at different levels of detail. The 1:100 scale volumetric model was simplified by reducing or eliminating the internal structure and simplifying some moldings. The 1:50 scale model was modified by designing joints for the architectural elements to facilitate semantic reading and was assembled from individual components. Additionally, different architectural parts were printed in various colors to help visually impaired individuals better perceive the differences. The printed elements were processed with the open-source Ultimaker Cura program and created with the Ultimaker S5 3D printer. After careful analysis, we opted for the use of fused filament fabrication, FFF, also known as fused depositing modeling or FDM technology. FFF is one of the most widespread technologies with the highest quality-price ratio. One of the project's goals was to share the methodology with a broader audience, and this technology, compared to the other technologies like resin, has simpler management that does not require the presence of a well-equipped laboratory. It should be noted that the 3D printed model used has a dual extruder for the material and the support. This feature allows for greater flexibility in the times and methods of making the 3D printed pieces. A study was conducted to test the best orientation of the elements to be printed in 3D printing chamber to reduce and eliminate any printed defects. The printed 3D models were tested with visually impaired students in higher education at the Invisible First Multiplier event in July 2023 in Thessaloniki and in Bologna in May 2024. Feedback was generally positive, especially regarding the scale of the models and the section cuts chosen to communicate the spatial and geometric characteristics of the architecture. Among the critical issues was the printing material used. The plastic often has edges that are too sharp and can be hostile to the touch. Furthermore, the characteristics of the layer 3D printing technique produce a jagged effect, which can be mistaken for a surface feature of the 3D model. To address these issues, post-production techniques can be used in some case studies to eliminate these problems. For example, sharp edges can be filed down, and curved surfaces can be smoothed to allow for correct tactile reading. The exploration of these models within higher education courses must be assisted by a teacher or expert who can guide visually impaired students in understanding the architectural space and its superficial and formal characteristics.